Good afternoon, and welcome to today's webinar entitled High Performance Bicycle Chain Formulations for Pro Athletes. My name is Abimbola Olalukon, one of the committee members of the IMechE Tribology Group. My background is in medical device tribology, so I'm no expert in the lubrication of bicycle chains. However, I will be trying my best to relay your questions to Dr. Kayemba, who will be our speaker today. I would encourage you to please put your questions through during the live webinar, and we should have up to 15 minutes at the end of the webinar to discuss questions. Now, to introduce the speaker, Doris Kemba is a senior engineer at JCB, responsible for engine oils and coolants for JCB machines. Prior to joining JCB, she worked as a tribology and formulation manager at IMechE, where she was involved in formulating bicycle chain lubricants and supporting pro cyclist teams during races. She spent 2 years as a research engineer at the MTC, employing laser surface texturing to various applications to improve their performance. She holds a bachelor's degree in chemical engineering from Tokyo University of Agriculture and Technology and a master's degree in the same field from Loughborough University. She received her PhD from the University of Leeds with research work focused on engine oil formulations of passenger vehicles. This was then followed up by 2 years postdoctoral research on engine oil formulation for marine diesel engines. So with no further ado, we would like to introduce Doris to speak on this topic today.
Good morning, everyone, and thank you for attending the webinar today, which is on high-performance bicycle chain formulations for pro athletes. My name is Doris Kayemba. I am currently working as a senior engineer at JCB, responsible for engine oils and coolants for JCB machines. Prior to my current role, I worked at a company called IMechE, where I was formulating and testing bicycle chain lubricants. So today's talk is centered around my experience from working at this company and to just explain a little bit more about the work that I did there. So for the talk today, we'll be focusing on bicycle chain lubricants, as the title is. But to get us started, I will first provide a brief overview of the bicycle drivetrain. This will help to highlight the specific target areas where we are trying to enhance with the chain lubricant. I will then talk about how lubricant validation tests are conducted and the various factors that we need to consider. I will then talk about performance of various chain lubricants in the market, highlighting the racing lubes and the marginal gains that can be obtained. I will end the talk by mentioning some of the challenges that I see across this particular industry, and then I will have my final conclusions. So on this slide is an image that highlights the main components of a bicycle drivetrain that we're concerned, especially with regards to the chain lubricant. You have the front chain or the driven sprocket. This sometimes can have 1 or 2 cassettes on it. When you have more than one chain ring, you also have a front derailleur, which is used to switch between the 2 chain rings or 3 chain rings. Then you will always have a rear derailleur, and this will have some idler sprockets on it, so 2 of them. And this is used to switch between different gears of the back cassette. So that rear cassette normally comes as a set of 6 to 12, up to 12 different chain rings, and these are mainly so that you can accommodate different gear ratios between the front and the rear chain rings. And of course, you have the bicycle chain, and that can be of varying length depending on the application and the type of bikes. Now, the chain rings can be made of different materials. So you have aluminium, you can have them in titanium, you can have them in steel. And of course, they come with different number of teeth on different sprockets. Again, that's related to the different gear ratios. Your derailleurs can be made of aluminium, again, as well as titanium, and this have smaller number of gear tooths to them. So that is the drivetrain that we are considering, especially when we're looking at on the bicycle chain lubes. So bicycles have been around for many, many years, and over these periods, we've had some gradual improvements, which means that the efficiency of the bicycle has improved significantly. So typically, the efficiency is considered as the power input from the rear, power input from output from the rear wheel divided by the power input from the front wheel. When it comes to the power, it varies depending on the type of riders. Elite riders can sustain a power of up to 400 watts, and sometimes they have very high peak powers up to 1,200 watts. But most ordinary riders will have a power input of about 200 to about 300 watts. And typical crankshaft speeds, these are your pedaling speeds. It could be something from 50 to 120 RPM. So from measurements, when you assess the drivetrain on its own, it has an efficiency of between 90 to 98%, depending on the test conditions, as we will discuss in the next few slides. What this means is that any marginal gains that we expect to obtain from various improvements that we can do to the drivetrain is only about 10%. That may seem like a very small improvement for everyday cyclists, but to elite riders, it could be a difference between, of a few seconds in determining whether they make it to a podium or not. Now, so the first question that we ask ourselves is although the efficiency of a bicycle is very high, up to 90%, where is the rest of the other 10% power loss coming from? Now, on the drivetrain, there are two main sources. So the first source is when the chain link engages and disengages from all the sprockets on the drivetrain. On a typical bicycle, there are about 8 locations where this process occurs, as indicated by the red circles on the top left image. These regions are referred to as articulation regions. To understand how friction losses occur at these articulation regions, we have to decouple the movement or the motions in the chain link. The image on the right breaks down the components of a chain. You have the outer plate and the chain, which is connected to the chain pin. Then you have the inner plate, which has a bushing, and of course you have the roller. Now, to put this bit together, the roller goes above the bushing on the inner plate, and the outer plates are connected together with a chain pin, and then you have your chain. Now, from some of the studies that have been done in this field to try and understand the percentage of contribution to friction losses, it's been found that the motion between the chain pin and the bushing accounts for about losses, and then for the motion between the bushing and the roller is about 48%. Now, this brings me to the second source of friction losses, and this is the chain offset. As I mentioned in the previous 2 slides, you have your front ring and you have your back ring, and at the back you have up to 6 to 12 different chain rings, and based on the position you are at, there's always an offset between the front and the back position, as you can see at the bottom, at the image at the bottom left. There's always an angle of degree offset from your front ring. So if you look at it from the top, so this chain offset also can contribute to friction losses of about 5%. So in summary, the main contribution to friction losses comes from the chain itself and the motions between the chain pin, the bushing, and the rollers, where the lubricant becomes very important. So if we want to assess the performance of a particular lubricant, we have standard testing that's currently being done by in the cycling industry. So there's one main system that is used. So this is normally a dyno, which is equipped with torque sensors that can be able to provide power loss real time. Now there are two methods that are normally used on dynos. One is known as the full load test method. Now with this method, you are simulating an actual bike where the chain on the dyno is not under any tension. Now that is a very accurate depiction of a bicycle chain. The only problem with this testing method is that it's not very possible to detect the very small changes in power due to friction losses. So there is an alternative method that is more accurate. This is the tension test method. Now this is used to ensure that you can actually measure small changes in power losses due to friction. And with this setup, you have the chain on a swing arm, and there's a load that is attached to that swing arm to ensure that the chain is always in tension. And typically when we are trying to determine how good one lubricant is from the other, we would typically use the tension test method. But that's not to say that the full load test method is not used. What would occur in some cases is that you would have your test running in the full load mode for a particular period of time, for example, an hour, 2 hours, or 3 hours, and then just to be able to determine how much friction loss you're obtaining at a given point, you would switch your system from a full load to a tension test for a few minutes, say 2 to 3 minutes, and then you will obtain your power loss measurements, and then you will take it back to a full load system and continue the cycle until you finish your test. Of course, that method of testing is quite long and tedious, but it does give you a true picture of the friction losses on your system. Now, when it comes to validation testing, especially for a bicycle chain, there are very many factors that will affect the measurements that you will obtain from your testing. This is not an exhaustive list, it's just an indication. So of course, it depends on the combination of the front and the rear chain rings that you have put, because different chain rings will result in different articulation angles of your chain, and that will have a significant impact on the friction measurements that you obtain. You have the chain length, again, because as I've just mentioned, a lot of the power loss comes from friction between the various, between the bushing and the chain pin. So the more chain links that you have, the higher the power losses. So it is no surprise when you have a longer chain having higher power losses compared to a shorter chain. Again, the amount of power that you are putting into the system will have a significant impact. The RPM, and another key parameter is the chain cleanness. So when you're trying to obtain very small changes in power losses, every single little bit of aspect of the chain will come into play. So if you have a factory as bought chain from a factory and test that and compare that to a chain that has been thoroughly cleaned and well lubricated, there will be a significant difference in the values that you obtain. Again, the chain age is another critical component, which we will look into in the next slide or so. the testing routine, and of course the lubricant has a significant impact, as well as the lubricant application method. I will talk about this in the next few slides. Now, the first thing, of course, we consider is the bicycle chain lubricant selection. And on the market, those of you who are avid cyclists will be aware of this. Those of you who are not, well, you will get some information on this. So there are different types of lubricants that are on the market. Broadly, you will find them referred to with terms such as dry, wet, or all-weather lubes. I will explain in a little bit what that may mean. But on the larger categories, these lubes can be grouped into either an oil-based lubricant or a wax-based lubricant. Now, with oil-based lubricants, this would be lubricants that when you apply them on your bicycle chain, they will remain sort of wet. But with wax-based lubricants, these are lubricants which you can apply either as a liquid in liquid form, or where you have your wax, you melt the wax and you apply your chain, you put your chain in the wax, and then you allow the chain to dry. In both cases, whether the wax is in a liquid form or in a molten state, you will apply the wax on the chain and allow it to dry. So before you use the chain, the wax will have dried and it will be almost as if it's a coating on the chain. So you end up with either a wet chain or a dry waxed chain. And there are various reasons why you pick one over the other, which I'll discuss a little bit about that in a few more slides. So that's the first thing you do: select your lubricant and then conduct your test. So as I mentioned, one of the factors in determining the performance of your chain is the chain age. And this slide here is just basically to give you an idea of the impact of the chain age on the performance. So if you take a chain and you use that chain over time, what happens, as I mentioned, there is always friction between the bushing, the pins, and the rollers. So what that friction, because of that friction, another process is going on. There is wear process that is going on. So over time, the length of the chain will increase. So there's always a chain elongation process that's going on as you're using the chain. And the graph on the right side is a study that was done by a company called Ceramic Speed. And they essentially took a new chain and took a chain that has been worn out at different stages with different elongation lengths. And they monitored its performance in terms of friction losses. So what you can see on this graph is that as you wear your chain, as the elongation length increases, you decrease the friction losses. So the y-axis is showing you a value, which is how much of the friction has been lost due to friction. So obviously, the lower the amount, the better. As the amount friction losses increases, it means that your friction basically is increasing. So what this slide tells us is that worn-out chains do not perform well. Newer chains have a better performance. So the other aspect that I mentioned that impacts the results that you obtain from your testing is the testing routine. Unfortunately, in the cycling industry, there is no standard as to how testing is conducted. So in most cases, when you get a new chain from a supplier, it will come with a factory grease. What you would typically do is you would take the chain, you will put it, you would clean it, and you will then subject that chain into a conditioning process. This is sometimes called also conditioning time. Again, the time is varied. It will depend from one chain lube manufacturer to another. Some will use a 2-hour test period, some would use more. And again, as I mentioned, there are other parameters that you consider: power that you're using, the speed that you're running that chain at. So you'd have your conditioning period first. So in this case, there are two results that have been published by IMechE. So they took some new chains, cleaned them, and then in the first graph on the left, they have subjected these chains to a 2-hour conditioning period. And then after the 2 hours, they've tested it. They've tested the new chains on a 2-hour period. And then on the second image on the right, they've taken the two the chains, the new chains, cleaned them, lubed them, and then they have subjected them to a 6-hour conditioning period prior to the 2-hour test. And as you can see, without going into details, the results are slightly different. When you take the clean chains and outright put them into a test versus if you take them, condition them, and then you test them, you might see some differences in performance. Now, this is just to highlight that the value you may see reported of, say, a lube A has this power loss is really subjective, because it really depends on how the testing has been done. And one of the things I said is, like, there's no standard of how this is done. So it really depends on different companies and what makes sense to them. So that's something to be very wary of. And again, the next thing is what values are reported. So from the image on the left, you can see that when you look at, for example, the blue line, it has, within the 2-hour test, you start off with values that is increasing exponentially, essentially. So you have a low value at some point, but then that low value is not maintained. It does increase. So what value do you report? What has been standard in the cycling industry is, rather than report an average value or, to cover whatever test period you've been testing, what people typically focus on is the lowest value that you can get. Whether that's correct or inaccurate is something to discuss, but that is something that is still up for debate. What is the most accurate value? Now, what are the what kind of improvement do we get from lubricants? Now, this slide is some work that was done by Ceramic Speed a while ago, and was just trying to assess what sort of benefit you can get from different lubricants that are currently on the market. And it's sort of this slide will give you an idea of how efficient or effective a lubricant can be. Now, when we look at this slide, we can see various lubes. Some of them are giving you a power loss below 4 watts. Again, the lower the value, the better. It means you're losing less power to friction. And we also see a high value of up to 9 watts by some lubricants. So, of course, if you're in the racing business, you want to use the lube that gives you the lowest friction losses, which will be on the left-hand side. So the range that we're looking for in terms of improving our efficiency from lube is essentially something between 5 watts, judging from the results from this graph here. So it's not a whole lot or much, but it is something. And as I mentioned before, when it comes to lubricant selection, you have different lubes to choose from. You have wet lubes, you have and you have dry lubes, which most of them are waxes. But again, so this graph just shows you the different types of equals. Some are wet, some are dry. So you're not really comparing apples to apples. It's actually more of apples to oranges or apples to bananas. So this graph illustrates one important aspect that I would like to highlight here. So you have all the different lubes irrespective of their types. We have the light ones in yellow. We have the dry ones, which would be waxes, some waxes in red. We have the heavy ones, which would be greases or slightly tackier lubes in green. And then we have the greases there in purple. And then we have some aerosols as well, which sometimes are used in blue. And again, for some of this, you could, they have also included what type of formulation that is being used in this lubricant. So with T, is a Teflon best. So this is a PTFE best type of lubricant. And ceramic, these are lubricants whose technology is best in ceramic. So this could be tungsten disulfide, it could be graphene, etc. So what this graph tells you is that you don't have one specific type of lubricant that outperforms every other type. So you can't generalize and say that waxes perform better than wet lubes. You can't say wet lubes perform better than waxes, or you can't say Teflon is better than any other lubes, simply because the data really depends on the whole formulation of the package. So, well, that's the good and the bad news, because there is no approach that you can take from that and say, well, definitely waxes are going to give you a better result. But that's not to discourage us, that there is still hope. So when it comes to racing lubes, what would we be looking for? So what are some of the considerations that we need to take into account? So when it comes to racing, we are not looking for endurance aspects as such, although endurance is a critical component. Some of these races are timed races, and in major races, you'll see them referred to as time trials, where you have a specific duration that you need to, that cyclists have to compete. So this could be several miles, and typically they range between 1 and 2 hours. So they have this duration where they have to compete, and they're assessed based on how the time they finish. Essentially, how long it takes them to complete that number of miles. And when you look at the bicycle, irrespective of the temperature, ambient temperatures, the drivetrain really does not operate at really high temperatures. We're looking at something below 60 degrees. So that's something that's very important, especially when you're considering the formulation aspect of the lubricant. And again, durability, as I mentioned, is not a critical factor, because you're not looking for durability over 500 kilometers or more. You're looking for durability within that 1 or 2 hours. So if your lubricant can be able to sustain that period, that's more than enough. And again, depending on where you're racing, you need to consider aspects such as depth, attraction. So again, this is one of the considerations that people formulating lubes would consider. So would a wax-based type of lube be more useful simply because it's less susceptible to depth attraction, or would a wet lube be a better preference? But again, even if it's a wet lube, viscosity is an important criteria, because then it can determine how well a lube can prevent depth attraction. And when it comes to racing, the chains are normally for single use. They don't reuse the chain every single time. In fact, they will use it for the 1 hour, and that will be the end of the use for that chain. So we're not looking for a chain that we need to reuse several times. So if we can optimize one chain for that 1 hour, that is all that we are aiming for. And again, I've gone through, the results for how much power loss or gains we can get with various lubes. So the target number really that we would expect from a really good lube is something around the 4-watt range, where you're only losing 4 watts of your power from your chain. And if you can get a lube that can help you reach that point, then you have a really good lubricant that you can use for racing purposes. And it can sustain all the various it can sustain that performance for 1 hour. It is durable and it doesn't attract a lot of dirt. So that is really the target that we're looking for. Now, when we look at the formulations that are currently out on the market at the moment, as I mentioned, a lot of this can either be formulated from wax, and this could be paraffin wax, beeswax, all types of different waxes. It's quite varied. And then the critical aspect here when we come to power loss is actually friction reduction from the chain, as I mentioned. And here there are different approaches to that. So obviously if you're using waxes or oils, the type of oil can also help in reducing friction. So in some cases using ester-based oils or mineral oils and mixing them together. And then the next bit is really your friction modifying aspect of the oil, of the formulation. So you're looking what sort of components can you add into the formulation to help with friction reduction. So on the market at the moment, we see tungsten disulfide, molybdenum disulfide, graphene especially is at the moment quite well used. PTFE was for some time, still is in majority of the product, as I have highlighted in a few slides before. And again, recently, some of the oils have disclosed that they're using ZEDP. But again, as I mentioned, the selection of friction modifier has to be very realistic, because one of the things we know is that temperature ranges do not go very high. So your selection of your friction modifier will be really dependent on the operating temperatures. Some of the friction modifiers that work well at high temperatures may not particularly be useful for bicycle applications, simply because of the temperature limitations. So that's something to consider as well. So what is currently being used in racing? So as I mentioned, the magic number in terms of power loss values, we're looking at around 4 watt power loss, and that gives you a lot in terms of power gain, essentially, or time gain. So on the market at the moment, we have a product called Absolute Black, which is a graphene-based lube. It is a wax, so you apply in liquid form and allow the chain to dry. And then, so that performs really well. And then you also have another one called Ceramic Speed, which again is a wax-based product. From a previous company, there's recently a product which was involved in developing, which is the Markov Ludicrous. It is a wet lube. So this is an oil-based lube. It doesn't dry up. Again, it has been a good contender. And we have Silco Synergetic Drip. Again, this is a wet lube that is based on tungsten disulfide and ZEDP additives in the oil. And previously, a previous company also developed a lube called Hydrodynamic, and this was used in previous racing for Team Sky. And it has won several awards. So the question is what type of performance you'd want. So waxes are really amazing as products, essentially because what you get as an end product on the chain is a coating of sorts. And what a coating affords you is that when you start your race, the coating already is able to perform very well. So it kicks in. It doesn't require time as a wet lube for the various mechanisms, adsorption, to kick in before they start performing well. So that gives the advantage to the waxes. And as you can see on this graph, although the values for the watts have not been provided, the green line here is for the absolute black. So you can see right from the start, you have an instant drop, and that drop is sort of maintained throughout the period of the 2-hour testing period. But that's not to say all waxes are great. The blue line here is, again, the ceramic speed, which is another wax, which when you start off, again, there is, although the value is slightly higher, there is a drop, which means that you are having some level of protection, some level of friction reduction. However, because it's a wax, by any chance, if the coating adhesion or the wax adhesion on the chain is not that great, with time the wax will wear off, and that can create some blockages on the chain links, on the rollers. That can even lead to higher friction. And again, once the wax is flecked off from the surface, there's nothing there to protect the chain from friction. And that's what we're seeing here, really. The friction increasing over time is because then you no longer have the wax that's protecting the surface. So the story is really two-sided. You can have, if you formulate a product that can stick to the surface well enough, then you have a really good performance. But if for some reason the coating or the wax delaminates from the surface, then you have catastrophic failure. Now, on the other side, the wet lubricants, if formulated very well, they can offer a real advantage over the waxes. Here are the two products, the one in orange or red and yellow. These are the wet lubes that I've mentioned, and they perform very well from the start. Yes, they may not give you, in that first instance, the instant drop to a lower value, but they can sustain a low value over time. You can see they get better over time. And in fact, at the end of the 2-hour period, they're much better than the absolute black, which had an initial lower value. So that is a real advantage. And the reason for this is that over time, the lube, because it's wet, it can flow into the areas that it needs to be, and provide you that sustained protection over time. So these are just some of the racing lubes that are out there, and people are still trying to develop better products. And I'm sure in the future, there might be some very competitive products on the market. So here, I just wanted to highlight a few challenges that I've encountered while formulating lubricants, bicycle chain lubricants. So the first aspect is the lack of standard testing. And you would find that different companies will have their own way of testing the whole process. And as I mentioned, different testing routines are very critical because the value you obtain could be significantly different. And that could mean between, one lubricant testing very well on a certain test and another one testing poorly in another test. But that's all dependent on the testing procedure, really. So there needs to be a lot to be done in terms of standardizing tests. Then the next aspect really is on the environmentally friendly side of things. Some bicycle chain lubricants are typically, when you're done with it, when you need to clean your bicycle chain, you basically clean it and drain the water into the common drainage. But if we're using lubricants that are not biodegradable, it means all of that is going into our water system, which is not environmentally friendly. A lot of work needs to be done to ensure that the oils that are being used in bicycle chains at least to have some environmentally friendly aspects to them to ensure sustainability. And as I mentioned, some of the lubricants that are still being used on the market contain PTFE in it, which is not the best additive to use. Some companies have taken the initial steps to phase out PTFE, however, not all of them. And there needs to be a way to limit some aspects of various components to be used in bicycle chain lubricants. And the last but not least is the fact that there's really a lack of research around the bicycle chains, the formulation of the lube. There hasn't been a lot of work around this area. there haven't been a lot of technical papers evaluating the performance of various lubricants. What we typically find is that a lot of the suppliers are the ones who are doing that work, obviously, which could be biased in one way or the other. So we need independent research that's done that can have an objective overview of the performance of various lubricants. So those are the main things from my perspective that I found that are still challenging within this industry. So in conclusion, what we've seen from today's webinar is that bicycle drivetrain is already a very efficient machine with an efficiency above 90%, but that leaves us room for gains with regard to various innovative aspects, especially with the lube aspects. And I've demonstrated that with different lubricants, you can see different efficiency gains of up to 5%. But there are still aspects that need to be considered, and these mainly are on the testing aspect. So how do we report various testing, and what is the right way to test, and what values do we report? Do we report the average? Do we report the minimum, maximum, etc.? And then we've seen that the lubricant performance is highly dependent on the formulation, irrespective of whether it's dry or wet. So it doesn't mean that waxes are better than wet lubes or wet lubes are better than waxes. It is all varied. So the development of high performance lubricants is still in its infancy, simply because there's not been much research around that area. But this is also an opportunity, just means that there is more to be done within this area. And I'm really looking forward to see what kind of products we'll be formulating in the next 5 years. So this completes my presentation today, and I'll be really keen to hear what you have to say. So I'm quite looking forward to some discussions with you. Thank you very much for joining us today on this webinar. And looking forward to your discussions.
Hi everyone, we're just waiting for Abby to come back online. We're just experiencing a few technical difficulties, so just give us 1 minute or so whilst we get Abby back online for the Q&A.
Hi everyone. Sorry, this is Doris. It's just we were just waiting for Abby, but since it's taking a few more minutes.
Hello, I'm here.
Oh, okay, brilliant. Leave it to you.
I do apologize for that. I think my internet connection failed me. So yeah, I would like to thank Doris for her time and for that presentation. I do apologize again for the technical issue that we have had on my end here. There are a lot of questions to go through. At this point, we probably have just under 15 minutes, so I'll push through them as quickly as possible. So the first question here is from Enrico Sassoni, and he's asking, bicycle chains have been bushless for decades, and why did you include these in your presentation?
Yeah, yes, I'm aware of bushless chains. So I haven't included them because I haven't done any work with them. So I have really no reference. So I can't really say much. I can't, for example, tell you they are better or worse off. So it's still something that maybe given time I'll research into. But I didn't during my time at Markov, it didn't get the chance to work with them. But yes, I am aware they are there. Thank you for that.
Thank you. And the next question is from Josh Palmer. What precisely limits the accuracy of the full load test method?
So this is really to do with the resolution of your torque sensors. And when you consider the full load test method, it's essentially you have, the chain that's going into your sprockets, idler sprockets. It's sort of, there's a slack there, so it's not in full tension. So when you're trying to measure a very small change in your power because of friction losses, as you can see, friction losses account to it could be a very small percentage. So capturing that with the torque sensors is very challenging. A lot of sensors will not pick it up. It's very difficult. That's the main reason why it's for accuracy purposes, where you're trying to pick 1% or 2% difference, you probably won't be able to capture it. So that's just the only limitation really for that test, but it's an accurate depiction of what a bicycle goes through.
Thanks for that, Doris. Doris, I'm still experiencing some internet challenges from my end over here. Are you able to read out the question and answer them for our listeners, please?
No problem. So we have a question from David, and he's asking, how is the power absorbed in the dyno text picture? So here, you essentially you have your you actually is it via friction under the belt and the tension? Yes, there is. So the test that we use to capture the sort of accurate measurements in terms of the friction losses, the belt is normally under tension. So typically in that image, what you've not seen there is that there would be a swing arm, and that swing arm at the back end of the of that back chain. So there will be a swing arm, and that swing arm there will be a dead weight on it. So that the chain is always under tension, and then that's how you can actually be able to capture the tiny changes in power losses due to friction. Then we have the next question, which is the magnitude of friction forces contributes for significant losses, but wear and loss of traction also contribute for the losses. What are the major loss contributors? Friction forces or wear effects? I think this is one of the areas where it's difficult to say for certain, because they're both one and the same. Because when you have a lot of friction, typically you'd also tend to sort of have slightly, wear they tend to come together. So it's very difficult to decouple the exact contribution simply from friction and simply from wear. I would say that it's very difficult to decouple because both processes occur at the same time. Then we have a question from David. You stated that the chain elongation introduces more friction than wear. Is elongation not caused by wear in the pins and rollers? Is there another aspect to elongation, i.e. Link plates increasing in length? So this is the same as just the previous question. So I think here the study did highlight the difference that you get more contribution from friction other than wear. But in my opinion, I think that the two processes, friction and wear, occur simultaneously. So I don't think it is possible to really decouple their contribution. We have a question from Peter, and he's asking, with extreme chain crossing, for example, using the smallest chain ring of a triple chain set with the smallest pocket of a wide 12 or 13 speed cassette, will the efficiency loss attributable to that configuration remain at around 5%? We have always been told to avoid such a combination. So again, yeah, obviously the combination of your front and your back chain rings will have a big impact in terms of the friction losses that you get. And yes, sometimes some configuration have, a bigger impact than others. And the main reason for that, as I mentioned in the first slide, is there is something called articulation angle, and that's dependent on the chain that you have. So if you have a very wide chain ring, say the front chain ring is really huge, like a massive one, of course the articulation angle reduces, and that reduces, well, in theory, your friction will be less. So as your chain ring, reduces, then your articulation angle becomes larger, which means you have a larger surface area for friction to occur, which means you get higher losses. So that could be the reason why there's always like, oh, don't use such a combination, because you will lose a lot of your power. And then we have a question from Simon. Many cyclists I speak to assume that the wet and dry nomenclature of the lubes on sale are related to expected weather condition. How does one choose a lubricant for wet weather or dry weather? Yes, so the nomenclature is a bit of it's sort of a black box. Nobody really knows. Every supplier has their own definition, and I'm sure cyclists, people who've been cyclists for a long time, they have their own understanding. Yes, in some cases, people think a wet lube would be used in wet conditions and a dry lube in a dry conditions, but there's also the other definition where a wet lube is like something that's oily, and then a dry lube is something that when you apply to a chain dries up. So there's those two sorts of definitions. But to answer your question, how would one choose a lube for wet weather? So even if you have a lube that sort of is wet in nature, it can be either of two things. It could be water-based or it could be oil-based. And if it is water-based, it means it can really wash away. But if it's oil-based, although it is wet, it probably won't wash away as quick as the water-based. So I would say the best thing is first, if it's not something that's a wax that's drying on the surface, make sure you check whether it is a water-based lube or it's an oil-based lube. You probably want to go for oil-based lube if you're thinking for wet weather. And then for dry weather, again, because there's no water, it could be either. It just depends on other conditions. Is it a dusty environment or not? So again, it really depends on your riding conditions there. Then we have.
Yeah. Oh, sorry. I was going to say that I could take it from here, but yeah, please finish what you were saying.
Okay, I'll finish this and then we'll take it from the next. Regarding lubricants, how do we balance the need for low friction coefficient and longevity of the lubricants? The lubricants are likely to deteriorate with operating temperatures and number of operating cycles. Yes, definitely. Your lubricant is, as you keep on cycling, it's going to attract. If it's, for example, a wet lube, when you say a wet lube, if something is flowing, if it's something is flowing, it is going to attract dirt, or dirt's going to be attracted to it, and it's going to become contaminated over time, and as it becomes contaminated, its efficiency is going to drop, and at some point, it's probably not providing the needed protection that you need. So I think if you're very keen on low friction, you probably want to be very cautious about your cleaning cycles, because then when you maintain very regular cleaning cycles, depending on the level of deterioration, then it means that you can have you can protect your chain from wear, because if it becomes very dirty, then you're going to wear your chain quicker because you're adding debris there that's going to be like abrasive particles, really. So you need to, yeah, I would say the first thing is probably your cleaning cycle should be more regular. I think that's the first step, because there's only as much you can do in terms of the formulation. The oil is always open to the environment, and there's always that. So cleaning cycles, I think that's the first thing I would say.
And the next question is from Ian. It says, are you able to comment on any general and obvious differences in performance between graphite and the graphene as lubricant additives in this application or in others?
So I know for a fact that both have been used as additives for bicycle chain lubricants. So graphite has been used for some time, similar to sort of similar type of additive molybdenum disulfide as nanoparticles or microparticles. So from the studies I've found from various companies that have done the assessment, they've found that the graphene performs better, obviously much better than graphite. So there is no dispute about that. Again, I think probably, yeah, there's no surprise there. So I think graphene tends to perform better.
Thank you. The next question from Josh. What is the nature of all-weather lubes?
So I think in this sense, you're probably trying to get a lube that would work in either, well, if you describe an all-weather lube as a lube that can work in different wet weather condition or dry weather condition, then you're looking for a lube that can be used in either of those conditions without having to worry. So that's essentially what you're looking for. In this sense, if it's something that's flowing like an oil, then you're looking for something that's more oil-based instead of water-based. So you probably don't want that because it may not work for all-weather lubes. And then if it's something that's a dry lube, for example, like a wax, then that can potentially be used in either application. But the key thing is to make sure that, especially when it comes to wet weather, that the lube that you use does not wash away. That is the key thing.
Thank you. So we are getting close to the hour. I've got one more question here, and then we'll put this to a closure. I do believe the speaker is able to provide some answers offline. So yes, because we do have quite a lot of questions that we've not been able to cover. So the final question for today would be: do you know how exactly the chains are conditioned?
So conditioning mostly is if you're for a typical rider, you don't do any conditioning. You would clean your chain, apply your lube, and off you go to your ride out. But if you're preparing chains to go into a race, it could be the long duration, typical duration race, or if it's just for time trials, then that's where you're really keen to make sure that when the rider starts on the chain, they're getting the lowest possible power losses. So that's to do that, you have to break in the chains, and there's a need for that. It's almost like breaking in, your engine, a normal engine. So what we would do is just it's almost like riding the chain for some period of time. That's the conditioning process, really.
Thank you. And
Yeah.
we are at the hour. We would like to thank Dr. Doris for her time and this presentation. We would also like to thank all our audience that's logged in from all over the world. We will endeavor to provide responses to some of the questions we were not able to cover. But I'd like to also share with our listeners that we do have a seminar, an online seminar coming up on the 30th of June, organized by the Tribology group of IMechE. It's entitled Tribology and the Journey to Net Zero on-road and off-road. So we would appreciate if you look at that seminar up as well and see if you're interested in it. So thank you very much once again, and we'll close the webinar at this point.
Yeah. Thank you, everyone, and have a good day. Bye-bye.